I'm Peter Oviedo, North America and Latin Channel Sales Leader for Fluke Reliability, and I'm going to be your moderator for today's event. Thanks for being here. Our speaker today is Jay Morel, Technical Manager at StarTech Instrument Systems, Inc., one of our most trusted partners for over 30 years for the states of Arkansas, Louisiana, Alabama, and Mississippi. Jay has over 35 years experience in maintenance and reliability. He spent the last 28 years at StarTech, where he fills his current role as technical manager. His duties include helping customers with technical field application issues, as well as supporting the StarTech sales staff with any complex or unusual applications. He manages StarTech's training department and provides advanced training in the areas of shaft alignment, geometric measurement, condition monitoring, and shop and field balancing. All right, you're here for avoiding alignment errors, improving accuracy and efficiency. Jay, take it away.
Thank you, Peter. Appreciate the introduction. Thanks to all of you for attending today. Hopefully, all of you will get something out of this. Let me first say that when I was first asked to present a webinar, I kind of looked at a list of topics and was trying to decide what exactly I wanted to speak on. And of course, I'm looking at a bunch of different things, and I said, you know what, let's just create something different, because what I really wanted to talk about were things that people kind of tend to forget or overlook. And that starts out as an every now and then kind of thing, and then it turns into then it just kind of drops from your day-to-day operation. And those things just kind of lead to longer alignments in the long run. We have broken this, or I did, down into 5 different sections. We'll talk about pre-alignment issues, entering dimensions, taking measurements and different measurement modes, soft foot, and then go into making corrections. So let me go ahead and move into that first pre-alignment section. Pre-alignment is something that has to be done every time. These are several steps that you just really need to do in order to do the alignment properly. Again, like I said, they tend to get pushed to the side when people are in a rush, or they just don't feel like doing some of them. And they just kind of end up falling by the wayside every time. These checks are pretty simple. The truth is, what you really need is you need to follow a good procedure. This pre-alignment portion is a good start on that procedure. So, pay attention. We'll go through these. Most of these are pretty simple. First, safety. Make sure we lock out and tag out not just the electrical power, but any type of power, any type of force that can cause this shaft to rotate or cause us any kind of damage at all. Safety is very important. Next, you want to visually inspect the base, the feet of the machine, the grout itself. Make sure there's no cracks in the grout. Make sure that the base is in pretty good shape, no cracked feet or anything of that nature. Nothing you can see, all right? Next step is to kind of loosen and tighten all the bolts. Hold down bolts, jacking bolts, all of them, no matter which ones they are, we're going to use them all. So you want to make sure that they are functioning properly. Maybe even lube up the jack bolts a little bit so that we don't bind them up trying to move a bigger machine. Clean around it. Clean around the machine, clean under the feet, blow everything off, wipe it down if you can. This just helps to make everything move freely. You don't want to be getting in a bind as you're moving it, or the thing kind of dragging as it moves. You'd like for it to move nice and smoothly. So clean all that mess up. The next thing we're going to do is we're going to pull all the shims out. We're going to kind of inspect them, make sure none of them are corroded, painted, bent shims, cut shims. We want to basically take them out and replace them. I would say that honestly, at this point, cleaning shims off is not a good use of your time. I assure you, you sitting there cleaning shims for 45 minutes is costing more than replacing all the shims with new shims. Just bear in mind, you can always clean them later after the job is done, but you don't need to do that right now. Next thing you want to do, last part of this, is you want to make sure with all the hold down bolts loose on the motor, pump, whatever, we want to make sure that there are no obvious gaps underneath the feet. Just kind of use either some shims or feeler gauges to feel them out. You find a gap, fill it up. All we're really trying to do is to build a pretty good foundation to start our alignment from. Next step is entering dimensions. When entering the dimensions, accuracy is a very important step here. It's the one thing you need to pay attention to. And bear in mind that some dimensions are more important than others. When you're dealing with a machine that is or a shaft alignment tool that is a single laser and receiver setup, we really only have one critical dimension to worry about. And that's going to be the distance from the receiver to the center of that point of power transfer, where the energy goes from the driver to the driven machine. That dimension is a critical dimension. And when I say critical dimension, what I mean is dimensions that if we enter them improperly can literally change whether we're in or out of tolerance. If you're dealing with a laser alignment tool that has either a reflected beam or a dual laser beam system, we're going to have a second critical dimension, and that's going to be the distance between the heads. That dimension also becomes a critical dimension. All of the other dimensions are not that bad. Critical dimensions, we want to measure within about 1/8 of an inch. The other dimensions, say where the feet reside, the shim corrections are going to take place. And you could be off of these by 1/2 inch, depending on the size of the machine, as much as 1 inch, and not really have much of an effect on the alignment process. Yes, you're not going to be 100% accurate with your result or with your correction, but in all honesty, with the tolerances, you're probably not going to really notice much of a difference. When we're entering dimensions, the next part of this is going to be if we have any targets or thermal growth on the machines. So we definitely want to be aligning machines as much as possible, not to a cold position or not to a zero position when they're cold, but we want to have either thermal growth or targets added in to be aligning these machines to where they're going to reside when they're actually running. We're trying to set it up to where once these things are under normal operating conditions, the two shafts are collinear at that point. In order to do that, we're going to either enter some thermal growth or targets on some of these more critical machines. And just entering them as possible. The top left-hand image on your screen right now is our thermal growth screen, where you can literally just, if you have numbers that you're working with from past experience, engineer gives you some thermal growth numbers he wants you to use. It's simple enough to just add them in. If, however, you don't have them, you can also calculate those. If you look at the screen below that one, the bottom left is our thermal growth calculator. I think most current machines, laser alignment tools, have a thermal calculator in them to calculate the growth of the machine. Pretty simple. You just need the current temperature of the machine, what it's going to be, what its running temperature will be, and what the type of metal it is that's the body of the machine is made out of, as well as the height of the machine. And the box will calculate that thermal growth for you. If we're going to use targets, it's a little bit different. And I will say that, speaking of targets, that some of our competitors don't really enter these numbers at the feet as thermal growth. They calculate the growth and then enter a target as to where they want to align the foot to. In our case, we actually enter the growth itself, and the instrument decides where we need to align it to. Some people enter what I would refer to as foot targets, telling that machine, hey, I want to leave this foot in this position, that foot in that position. It's just a difference of terminology and the way different manufacturers of these alignment tools handle this, okay? We're going to talk about coupling targets now. So this is the other way to deal with thermal growth. Targets are not something you kind of calculate by the fly most of the time, but over time you may take thermal growth, somebody may, and transpose that into targets at the coupling and just basically say, hey, look, enter this at the coupling. This is telling it where I'm going to leave the coupling, the right coupling half in this case, the movable machine, in relation to the left coupling hub. You'll enter it as vertical offset and gap and horizontal offset and gap. And again, this is telling it where I'm going to align the machine. That is the difference between how we view thermal growth and targets. Thermal growth, I'm really telling the machine where we're going to align it at, or what's going to happen to the machine. The targets, we're actually telling it, this is where we're going to align the machine. We do consider this to be part of the dimensions because it's something I'd like to do up front. That's why it kind of got crammed up here in the front of this presentation. All right, first poll question here. Can't hear Peter, but I'm assuming that he's talking.
No, I'm not talking, but are you ready for the answers? I don't know if you can see them or not, Jay.
I cannot.
Okay. Let's give it a little bit. Let me just go ahead and close the poll. So it looks like right now, what? Oh, you switched up. It looked like it was very low on the straight edge feelers, 10%. Thank goodness for that, right? Dial
Yeah.
indicators was about 17%. The proof technique fluke reliability lasers was about 45%, and the other systems were 29%.
Okay, good. I was just curious. Interesting data. All right, let's move along. We'll start talking about taking measurements. So before I get into the different measurement modes, what I'll say about taking measurements is the real value of any shaft alignment system, any way you do it, is how accurately it can calculate the relationship between the movable shaft center line to the stationary shaft center line. A couple tips. One of the things that I'll say is you want to always rotate the shafts in one direction. This is something that we teach in all of our classes. And I think early on, people kind of misunderstood what I meant. But basically, I know a lot of times people will start rotating the shafts and they get to a point where maybe there's an obstruction there. They can't rotate the shafts all the way around. Well, they'll stop the measurement, rotate the shafts backwards, and begin another measurement. I'm not saying you won't get the job done at the end of the day, but I promise you, if you never rotate those shafts backwards, it will shorten the amount of time you spend doing alignment. You rotate the shafts as far as you can just before you hit whatever obstruction, if it's the base or piece of pipe, the bottom half of a coupling guard, whatever it may be. Stop your measurement. And at that point, you want to loosen the bracket itself, loosen the chains, rotate it back on the shaft as far as you can, rotate the other one, center the laser back up, and then start another measurement from there. A lot of people get kind of confused because they think because these things are so accurate, we can't really move any of that stuff. Well, I'll tell you some of the advantages of our system is you can do that. We have no problem doing that. It is honestly the way it should be done. I will say when you go to put the brackets, tighten them back up. Make sure you're not leaving the bracket on top of a key or something that could possibly move while you're rotating the shafts. But other than that, we have absolutely no problem moving the brackets on it. You could literally take the heads off, take the brackets off, hand them to somebody else, let them put them back on, take another measurement, go in the same direction. You're going to get the same answer out of it. Should anyway. So don't be scared to do that. It will increase your repeatability tremendously. Also, just when you're rotating it, be sure that you're not pushing or pulling on the shaft. The idea is just to rotate it. And honestly, if it's really difficult to rotate and you're having to flex your muscles to rotate it, we would probably switch to a different measurement mode than just the default sweep measurement. But we're going to talk about modes in a second. So just try to rotate it and not push or pull on the shaft as you're doing so. You also want to select the proper measurement mode. This is probably, the most important part of this, because whether you rotate it back and forth or not, you're eventually going to get there. But if you use the wrong measurement mode, it could take a lot longer to get there. So, we're going to talk about these measurement modes now and, what each one of them is used for. There may be some questions about that later. I'd be happy to answer them, but I'm going to try to go through them and discuss the different measurement modes, the options that are available, and why you would use one over the other. The default measurement mode of our box, all of our boxes, is the sweep or IntelliSweep, depending on the instrument itself. A sweep measurement basically refers to the fact that we're just going to rotate the shafts. The laser's sitting there flashing, the receiver's collecting all these little dots as it throws them at the detector. It takes a lot of data, covers as wide an area as you measure. And because of the amount of data and the speed with which this measurement is taken, it is the default. And it does actually come out to be a very accurate and repeatable measurement. The difference between sweep and IntelliSweep, sweep is the default mode of the Optoline, IntelliSweep being the default mode of the Rotoline systems. With the IntelliSweep or any of these measurements that say Intella, you're going to see a visual of it later. It literally looks at the data that is collected during the measurement, and it decides whether to keep all the data or not. You can see up in the top left-hand corner of your screen, that is the measurement mode that is displayed there. And you can kind of see it gives a little brief description of how the measurement is taken and what it's used for. Again, this is the default. So for normal machines, regular standard pumps, fans, general machines with rolling element bearings, those would all be considered machines that we would do a sweep measurement with. The next measurement mode will be the IntelliPoint measurement mode. Bear with me for a second here. I've got a problem. The IntelliSweep or the IntelliPoint measurement mode multi-point or IntelliPoint, again, depending upon whether we're talking about an Optoline or a Rotoline. So the point measurement modes have pretty specific uses. Point measurements are most often used in high vibration areas, really high vibration areas, shafts that are difficult to turn, or sleeve bearing machines. These measurements are all affected by external forces, and sweep really just isn't the greatest measurement mode to do that. You would eventually get there, but you would probably make a few extra moves to get there from that point. Basically, the way this measurement mode works is instead of measuring while we're rotating the shafts, you're physically rotating it, hitting a button to take a reading. The instrument takes a group of measurements, depending upon how much background vibration it sees and how stable the measurement is. It will determine how many measurements it needs to take in order to get a good average. It then looks at all those points, averages them together, and then we move on. We rotate it a little bit further, take another point. At the end of the measurement, when we're done and we've got enough rotation and enough measurement points, the box is only going to use the points that are averaged out of those groups to calculate the misalignment of the machine. This type of measurement really helps when you're having to turn something that is difficult to rotate, something you got to turn with a tool. Because bear in mind, anytime I use some type of tool, strap wrench, pipe wrench with a 6-foot cheater pipe on it, all that kind of stuff. Anytime you use those types of tools, you are definitely going to push that shaft off its rotational axis. You're going to affect the measurement. This measurement mode is also a pretty good measurement for uncoupled shafts, as long as we can stop the machines where we need to stop them at. It's a very good measurement to do uncoupled measurements with, as well as the background vibration, shafts that are difficult to turn, any sleeve bearing machines. Sleeve bearings kind of get affected as you rotate them by the oil that's still sitting in that babbitt. As you rotate it, it kind of pulls that oil and lifts up the two ends of the machine. You know, realistically, you think that's what we want to happen. The problem with that, though, is there's no way for you to know how much oil was in the front bearing, how much in the back bearing. Therefore, you don't know what angle that shaft is sitting at, because it may be sitting on more oil in the front than the back. This is a problem. So when you do this, you need to make sure that the shaft has settled. This is a function that this Intella algorithm does for us. It watches after we've stopped rotating the shafts. It will not allow us to take a measurement until not only it sees that the rotation has stopped, but also that the movement of the shafts themselves settling back into those bearings has stopped. It's a pretty powerful measurement mode. Next measurement mode we're going to talk about is the pass mode, or again, IntelliPass, similar idea. The pass mode is great for uncoupled shafts when you can't stop the shafts where you want to stop them. So you basically will center the heads up. You're going to rotate one few degrees, 20, 30 degrees, something like that. Then you're going to slowly, gradually rotate the other one past it. Again, another 20 or 30 degrees past it. And we'll just keep kind of going back and forth, turning one shaft at a time, slowly as it passes across, as the laser passes across the sensor. It's going to take readings, and it's going to then calculate a result from that. So we basically got two measurement modes that we can use in that pass sector. Uncoupled machines. So what I'll say is measurement quality matters, and most current alignment tools have a way that they give you a measurement quality indicator or a quality uh, factor of that measurement. Um, they're looking at things like how far you've actually rotated the shaft, um, how many measurement points we've taken, how stable the points can be in there, all of these kinds of things, the standard deviation of the measurement itself. All these things kind of get added together to give you some indication of whether the instrument believes you have a good measurement or not. Um, you'll notice on the screen in front of you that blue shaded area going around the coupling there. Um, that is our quality factor. And that is basically, you can see on the bottom left-hand corner, it says the quality's at 100%. The box is quite certain that it does have the right result, but that color will go from red to yellow to green, then to blue. Of course, each of those colors has a meaning, working their way all the way up to the blue, where we feel quite confident that we have the right answer when we see that. Again, you know, the Intella stuff kind of factors into that. And we're fixing to take a little better look at that. So this is an IntelliSuite measurement, okay? So just to give you an idea of how this IntelliSuite mode works, you see all of the gray dots and a few white ones there. All the gray dots symbolize all of the measurement points that were taken that the instrument decided it was going to use. The ones down in that bottom right-hand corner where you see there were measurements taken, but they are basically not shaded in, you'll notice on the bottom of the screen, those are inactive points. So the box or the instrument, through that Intella algorithm, determine which measurement points to use and which ones not to use. In this case, it looks to me like this was probably somewhere where somebody rotated the shafts, got to that point and let go of the shaft, going to grab it again to get another bite and continue rotating. Maybe the shafts kind of backed up a little bit, or even just backlash in the coupling that showed up, and the instrument just said, you know what, I'm taking these out. They don't have to be in here. I'm taking them out. We don't try to affect that in any way, although there is the ability to turn some of those points on or off. I would recommend to everybody, leave that alone, let the box do what it does. It does a pretty good job of it. It's all done automatically. There's no need for you to intervene. So what do we do when we're trying to align a machine that we just can't get repeatable measurements? And what I'll say about that in our tools is, if we're not getting repeatable measurements, then something's not repeating when you take the measurement. And I know that sounds reasonable, but what I mean is there's probably some type of mechanical problem in the machine. Could be a bad bearing. That is really the most likely answer. You'll notice top left-hand side, we're looking at the measurement table inside the Rotaline Touch. And the last measurement has a little check mark to the left side of it. That check mark tells me that that is the measurement that is selected. And when I go and hit the result key, that's the measurement that I'm going to make the correction for. If you look at the other screen to the bottom right of it, you'll notice that all of those measurements, all 4 of them, have been checked. And what it does then is it averages all of those measurements together. The 4 vertical offsets and vertical angles, the 4 horizontal offsets, and the 4 horizontal angles individually get averaged to give me a more stable measurement. This is not something you're going to use very often. In fact, it's probably something you'll even forget is there before you ever need to actually use it. But we did include something in that box to be able to handle that. So that is something to keep in mind if you have an issue. So now we're going to talk about soft foot. And I will say that this is probably one of my biggest pet peeves. This is something that drives me crazy. On occasions when I do go out and just basically help a customer, do some field type training for them. And we walk up to the machine, they throw the instrument down, add some dimensions in, they take a sweep, they go to results, and they start moving machine. Soft foot is not an option. It is something that needs to be performed on every machine, because if you don't go measure it, you don't know if you have that soft foot issue. And please understand that the issue with soft foot is not just the fact that when we go to tighten the bolts after a move, it's going to move the machine as we're tightening the bolts. The problem is what a soft foot really is. What the result of a soft foot is internal misalignment in the machine. So even if my alignment result says that that machine is, let's say, very close to perfectly aligned, realistically, that machine still has a problem. With the internal misalignment in it, it's going to struggle. What I will say is, I teach a 3-day advanced alignment class here at our office. And in that 3-day class, I generally spend somewhere around 3 hours on soft foot. We don't really have the ability to do that today. So it's going to have to go by the fact that I'm telling you this is something that you really need to do. Leaving a machine with soft foot can cause severe problems: premature seal wear, bearing stress, alignment instability. In extreme cases, it can even cause failure of the shaft. I have seen it. It does happen. I promise. One of the problems that people have when doing soft foot with a laser alignment tool is the ability to take the results that the alignment tool gives you, let's say in that first measurement, and figure out how to convert that into actual corrections. Because realistically, the box is telling you what it sees, but the truth is those aren't really 100% the right answers. So we actually incorporated into our Optoline and Rotoline a function called the Soft Foot Wizard. Its purpose is to diagnose what the actual problem is with your soft foot. And then basically it'll give you some instructions as to how to feed it more information. And at the end of the day, it's going to come up and give you, hey, this is how you need, what the correction you need to make. And you make it, and then it has you go back and check again all 4 feet to make sure that we have resolved the issue. And hopefully, by the time you run through all these little arrows through the soft foot wizard, at the end of the day, you end up with a little smiley face on the soft foot screen. The soft foot wizard is an extremely powerful tool. It's getting better all the time, but I would suggest that you use it. Otherwise, you're just kind of guessing at what the results could be. All right, here's our second poll question. How often do you perform soft foot checks? I'm really curious about the answer to this one. Again, I see it a lot of times that only if I see a problem during alignment, but I'm trying to get it to where everybody does it on every alignment. So please answer the poll question. And Peter, let me know when you see some results.
Okay, we're about 40% voted so far, Jay. Let's give it just a little bit more, and then we'll see where we end up. Currently, right now, it looks like it's on every alignment. It looks like that's the most so far. We're at 60% voted. Okay, it looks like right now, based on the poll that we have, Jay, it looks like 57% are saying on every alignment. 35% are saying only if they see a problem during the alignment, and only 5 say never. And what is soft foot? Only 2% said that. So It's good news.
I needed another answer. Okay. All right. So I normally wouldn't take this poll question and make another statement based on this, but I'm just going to reiterate to the guys that only if you see a problem, just because you don't see a problem doesn't mean you really don't have a soft foot. Soft foot can also, I guess I didn't say this before. I kind of missed this little blurb in my outline that I created here. But soft foot doesn't mean it's a foot problem. This could be a base issue. It could be due to some pipe strain. It could be due to something totally different. And if you have pipe strain and you're fighting it through the alignment, you've definitely got internal misalignment in the machine. And I realize when it comes to pipe strain, there's not really much you can do on the fly when you're just out repairing a machine. It is a good idea to make a note of it. Let the people who can make change happen know, because I would suggest in the next outage that issue gets resolved, because it is always going to be a problem until you fix the problem. All right. Let's continue on. Making corrections. So this is the fun part, right? The only thing I'll say before we actually go into this, just kind of tip wise, is that before you actually hit that move button on the machine, or before you're actually live, I would look at where the heads are positioned and move them somewhere where I don't have to worry about bumping them as I'm trying to loosen the bolts or move the machine. Or if you're leaving it sticking straight out to 3 o'clock or 9 o'clock position, you got to be careful not to actually, especially if you're going to be moving it with a hammer, you probably want to turn that either straight down or straight up. So normally the way I recommend people leave them when they're making a live move, if you start tapping that thing with a hammer, we all have to do it at times. That shock's going to run through that machine to that shaft and can cause that shaft to just start rotating and affect your measurement in that correction. If the shafts turn, my suggestion is stop, tighten the bolts down, go take another measurement. I really don't care what type or kind of laser alignment tool you're using. If your coupling has any backlash in it, you're rotating it from one side to the other. If you're turning it back and forth, it's going to affect the results of the move. Tighten the bolts, go take another measurement, and then come back. So, end results. When you start moving the machine, again, be careful you don't bump the heads. Let's get it as close as we can, guys. One of the biggest complaints I hear from engineers about the smiley faces on the machines is guys see that smiley face and they stop. Try to get it as good as you can. There is a point of diminishing return somewhere, but as long as it's moving the way you want, you're getting the results you want, continue to make corrections. Let's get it close. The two different views that you see here are the two views that are available in all of our tools these days. You've got the two-dimensional view, which has been the traditional view in the rotolines for 30 years or whatever. It did get moved into some optilines and shaft aligns along the way. Those tools all basically use the same firmware now. The difference is you're limited by the capabilities of the heads that you have packaged with your box now. So the views that you get for the most part are pretty much the same. The two-dimensional view is the one that I like. I kind of say grew up on rotolines. I've been using rotolines. I've been with StarTech for 28 years. So for that long, that's what I've been looking at, and kind of like the way it does graph everything to scale. So, when you look at that screen and you see the little boxes on the screen, the box is going to basically calculate what the biggest offset at the foot is. and it's going to scale those boxes to fit the screen. The scale of the box depends on whatever that biggest number is. As we get closer, that scaling gets smaller. One of the complaints people have against the two-dimensional view is that when you get it really close in alignment and you hit that stop button and it rescales to where those boxes are 1,000th or a half a thousandth, the misalignment looks pretty big, even though you're so close that you really couldn't get it much closer. That is the main argument I will accept for the three-dimensional view. Some people just like it better. Again, this is a preference. It doesn't matter. In both the Optiline and the Rotaline, when you hit that move button, you can see both vertical and horizontal live simultaneously. That is very powerful stuff because, in all honesty, I want to see that. I may zoom in on the horizontal as I'm just moving in horizontally. But before I start tightening the bolts, I'm going to come out back to that both view where I'm looking at both vertical and horizontal, because I want to watch vertical and horizontal as I tighten the bolts and see how all of that's being affected as you tighten. We get everything tight. We get a little smiley face on the screen. We're going to go back and take another measurement. That measurement, of course, is just to verify that what we think we have is actually what we do have. If not, of course, we're going to make another correction and continue. If we've got it, we're going to save that file, generate a PDF report. Most boxes can generate a PDF directly from the instrument to a little thumb drive. In all honesty, all of these newer tablet style boxes all have the ability to email the reports directly from the box to the to anybody, basically. So you don't even have to generate the report. As long as you can connect the box to Wi-Fi, you can spit the report directly out of the box to whoever you want to send it to. They can be around the world if that need be. Doesn't matter. So that report, to me, is important to the people that you're doing this alignment for, whether they're your bosses or whether they're your customer. Those reports are important. That's pretty much all of my presentation. I would like to point out that StarTech and Fluke Reliability are going to be hosting a road show at the LaBerge Hotel and Casino in Baton Rouge on November 13th. It is an 8 o'clock to 4 o'clock training class. We'd love for you to come out and visit with us. No charge for the road show. We're going to supply breakfast, lunch, snacks. The hotel does have rooms available, blocked off at a discounted rate for us. While the webinar is free, hotel and any other gambling outside of that falls on you. So with that, I'm going to conclude this. I think we've got some questions potentially. Peter, you got some?
Yes, sir, Jay. Just so the audience, you can post your questions up there at the top right if you have some questions already, while I'm asking Jay these ones that have already come in. Jay, here's one question. How do you check soft foot on a machine with more than 2 sets of feet?
So when you're dealing with a machine that's got 3 or 4 sets of feet, there's really no way for a laser alignment tool to measure those middle feet. All right. We can only measure the 4 outside feet. So in order to do that, what you need to do is pull all the shims out from under the middle feet, allow them to just have a gap underneath them so that we can see how the body of the machine flexes while taking the measurements only 4 outer feet. Once you've got that done, you're just going to go back and kind of fill the gaps under the extra sets of feet there in the center. Laser alignment tools just don't have the capability to measure those center feet. If you think about it, as you start to loosen and tighten those, they cause some movement in the body of the machine that the instrument's not going to recognize. It's going to see it totally differently. So, we kind of, while we can measure it on that machine, we can never measure those center feet. They have to basically just be filled at the end of the day. Now, once you get them close, you can use a mag base and an indicator if you want to just check to see that there's no sponge left in them. Usually just filling them is enough.
Okay, thanks. Here's another one for you, Jay. What is the appropriate shim size for the motor machine feet? And what's the minimum acceptable alternative if correct shims are not available?
All right. So basically the rule on that is that at least 75% of the surface of the foot needs to be covered by the shim. I will say, however, if you don't have the shims, you're kind of stuck doing whatever you can. But in reality, at least 75% of that foot, and I would like to see 90% of it, but at least 75% of the foot should be covered by the shim surface.
Okay, great. Thanks. That's definitely helpful. Another question that we have here is how much of the alignment accuracy is about the instrument and how much is it about the operator?
Well, that really depends on the instrument you're using, the measurement type, and who the user is too, because the user, I guess, if he wanted to, could always affect it. I'll go back to the rotaline and its IntelliFunctions. The goal of the IntelliFunction or the algorithm is realistically to take the guy who's doing the alignment to just completely take him out of this process. So at that point, I always say in my training classes, look, I'm not going to make the statement that you can't get a bad measurement because people take that as a challenge. But I will tell you that you're going to have to try with that rotaline and those IntelliMeasurements as long as you're using the right measurement mode. I can't stress enough how important it is to use a multiple point measurement, a point type measurement on sleeve bearing machines and shafts that are difficult to rotate. Again, whether you're using a tool or not, if you've got to flex your muscles to rotate that shaft, you are probably affecting the rotational center line of those two shafts. And you really shouldn't be doing that while it's measuring. Therefore, you shouldn't be taking a sweep measurement.
Okay, great. Here's one more for you, Jay. Looks like we still have about 10 minutes. All right. So let me just go ahead and ask this one here from how do you feel about parallel misalignment that is within a smiley face values, both the vertical and the horizontal?
So look, if that is, as far as I'm concerned, and we've been at this for years, that smiley face is all that I have to have. Okay. Having said that, as I mentioned in that live move section we were talking about, if I can get it better, in other words, if I go make my first correction, I don't have any problems moving the machine, tighten the bolts down. It's not jumping all over the place when I do that. I go take another measurement and I'm off by, let's say on an 1800 RPM machine, I'm off 1,000th in the vertical and 1,000th in the horizontal. I'm probably not going to worry too much about it. But if I feel like it's close enough to the tolerance, I'd like to go ahead and make a correction. If it's a 3,600 RPM machine, at one, you're right there on the edge of the tolerance. And yeah, you could probably get away with it at 0.9 and 0.9, but I would still like to move it a little bit closer. Get yourself away from those tolerances. Look, we all know, based on thermal growth, but let's leave thermal growth out of it. Just the dynamic forces that are going to happen when you fire that machine up, they are literally going to cause that rotational center line of that machine to move. We've seen it time and time again in our live trend function, where as soon as you start that machine up, you'll see the machine rise or drop or move in the direction of rotation or towards the end user, toward the guy who's taking the readings. And that doesn't have anything to do with thermal growth. These are unbalanced forces, misalignment, even the process that's going through whatever, the pump, the fan, whatever that is, the hydraulic forces in a fan, all these things affect the position of the shaft. And if you're sitting right on the edge of the tolerance, unless I just can't do any better, I'd like to see you get a little closer to the center line. But if that's the best you can do, it's the best you can do.
Okay, great. Thanks, Jay. Here's another one. Is using live trend the recommended best practice to perform hot alignments versus taking down the unit once it's at operating temperature and doing an alignment as close to operating temperature?
Man, I ought to send some money to the guy that asked that question. I'm going to tell you that is definitely the way it should be done. You got to bear in mind, like all the stuff that I just explained, these are things that can't be calculated. So, we're going to account for thermal growth, right? So we've calculated what the thermal growth for this machine is. We input it and we align it to that. You still have all of those other factors that you can't calculate. They literally have to be measured. But you also have the issue of when you're doing a hot alignment check, the problem is generally, first of all, when you shut the machine down, you lose those right off the bat anyway. Because as soon as that machine stops rotating, those forces, those things that are being injected in by the rotational inertia of the rotors, those can't be measured at all once that shaft has stopped rotating. It has to be measured while the machine is running. But even on top of that, the second that machine stops, the process stops flowing. The machine starts changing temperature, especially if it's really hot to start with. It cools much faster at its max temperature. As it gets closer to ambient, the cooling slows down. It's generally not a situation in most places I've been in where we can just, standing at the machine, push the button and stop it, throw the brackets on and take a reading. Generally, I got to go sign off these tags. Somebody's got to pull them. Then we got to mount brackets, take a reading. In that time, we've definitely lost some of the actual thermal introduced growth of that machine. So I would tell you, I'm not saying on every little pumping motor that you go align, but on any critical machines, I truly believe this is the only way to accurately know where those two machines are in relation to each other when they're running. It's the only way to know if you're doing this right or not.
Okay, great. Thanks. We've got time for a couple of more, maybe.
Yeah.
How in your experience, Jay, have you dealt with direct sunlight on some laser alignment systems that are directly impacted by sunlight?
So first of all, I will say that, the laser system you're using matters in that realm. I'm going to say that, everybody asks this question every class I teach, and bear in mind that these detectors are light detectors. So right off the bat, that just tells you there's an issue. But I can honestly say that with these Sensaline 7 and 5 heads, so the heads that are within the Optoline and the Rotoline system, we've not seen I mean, I'm not going to say never but I can't honestly remember anybody coming to me with those problems. You remember back in the old days with the old Rotoline heads, this was a huge issue. Those were greatly affected by it. And I say affected by it, and I guess that's the wrong term, because our measurement wasn't really affected by it, because if the instrument saw it, it just basically gave you a message on the screen that said ambient light, and it just wouldn't allow you to proceed until you resolve the issue. What I want you to think about, and this is going to pretty much be the case with most laser alignment tools. I guess some laser alignment tools, the detector is literally sitting on the face of the head. I'll tell you, those are extremely susceptible to sunlight issues, but they won't tell you that you have an issue. It just affects the reading itself. But any that have the detectors inside of the head, really the issue is not light coming from overhead. It is light that is being reflected from somewhere that is downstream of that receiver. And in most cases, if you just lean your head down and put it by that receiver, look the direction it's facing, you can usually see where that problem is. Might be a flange or something down there that the sun's hitting, just reflected light back at a narrow enough angle to get inside that head, and cause us an issue. You can walk down there and throw a rag over it, and stop that problem without it being a problem. So sunlight, again, they are light detectors, so it'd be almost impossible for me to sit here and tell you that sunlight can never be a problem. But I really can say that I've not seen any real issues in a long time from our current lineup of laser alignment tools.
Okay, thank you, Jay. As we come up to a closing time on this webinar, Jay, again, thank you for sharing your expertise today. This is what it's needed. We need this type of information from people that are actually in the field using it. And thank you again for joining today. Be safe.
Thank you, everybody.